Okay, I am Philip Austin, NGK Pro Training Manager for USA and Canada. Today's topic is testing ignition coil unplug types. The vehicle that we have here is a 2017 Chevy Trax all-wheel drive 1.4 turbo. This particular engine design has a rail-on coil. It's all consolidated in one. When you pull up a wiring diagram, you could actually see 1, 2, 3, 4, 5, 6, 7 pins in which you're checking for system voltage, ground, and then the other 5 wires is related to the ignition module control of that particular coil pack for each cylinder. So when we're looking at checking this type of ignition coil system, there's some tips in your approach. Right away, I would tell you that you need additional scan tool or scope capabilities, accessories such as a low amp current probe or even a wand, especially with this particular application, because since it's a consolidated coil pack, okay, in which it has the individual coil on plugs, but all into one molding, how you are testing the system is very critical. So the reason why I will recommend one of the two is when you use a low amp current probe, you're actually measuring the current of each one of those ignition coils and being able to see their activity and how much amperage is ramping up each coil. We do want to see some sort of consistency. Now there are ignition accessories such as a inductive wand that you could use. Now don't get mixed up with the data that you're seeing on your diagnostic tool or device, especially like I have the Autel here and then the Snap-on Zeus. At times the device that you're using may give you the indication that you're looking at KVs, but actually you're not. It's kind of just performing the virtual aspect of the KV kick, but you're not actually measuring the KVs of that one. It's just using its own math in order to show you a representation in form of a waveform on that. So you looking at that as a diagnostic step, you just want to make sure that that supposedly KV kick or what you're picking up on your ignition one is consistent with all the others in order to determine which ignition coil is not firing correctly. But it doesn't matter as long as you're able to find one that has failed, the whole thing must be replaced. So as you look at different vehicles that may be of a different design than this ignition coil pack system, then your diagnostic approach will change. For instance, if you have an individual coil unplug pencil type, actually individually going to each coil, now you want to set up your diagnostic approach of, okay, is it a 2-wire, is it a 3-wire, or is it a 4-wire? Because if it's a 2-wire, then that's where, okay, power feed's coming in, the PCM is playing the power driver, so I just need to work on my primary circuit to see whether that is functioning properly. Using a low amp current probe and along with a dual channel scope and picking up that ignition primary control feed, you can look at that to determine whether that coil is operating. So you're looking at 2 aspects. You're looking at the current ramping and you're looking for your ignition control feed. So the PCM does the heavy lifting. And what I mean by that, there's no power transistor within the circuit in which is taking away to the PCM. The PCM is controlling the current flow by keeping the dwell time, obviously how long that ignition coil is being grounded. Now we switch to an application that is a 3-pin coil. Now that may have a power transistor in that where the PCM is not doing so much of the heavy lifting when it comes to controlling the dwell time and feeling the current flowing through that system to the same degree as a 2-pin. So your testing will change when it comes to that. And same method of using a low amp current probe along with second channel back probe into your ignition control of that coil, but also verifying that 3rd pin, which is a ground, because that ground serves the purpose to support the power transistor or the ICM that may be in the head of the coil. Now, moving on to a 4-pin coil, that engine management system means that it has a feedback circuit. So the same setup of the 3-pin coil, but now we do have an ignition control module that has the abilities to provide feedback, whether that coil has actually fired. Like on Toyotas, they would call it the IGF. Other applications, they would just call it a feedback circuit, in which the PCM, every time that it controls the ignition primary circuit and brings it to ground, it's looking for that coil to fire, and that's its way to confirm it. So you may be asking, well, what if I have an application where I have a broken splice on that 4-wire coil and the PCM can't see that confirmation? Well, the PCM will go into some sort of default mode and kill the injector. So be careful with your diagnosis where you have an actual misfire, but it may be associated with the computer killing the injector because it lost the feedback confirmation due to a wiring splice problem or the 4-pin coil. So you see how your diagnostics could shift based upon the various steps of walking through a wiring diagram, checking powers, grounds, signal control, and also feedback circuit. So I hope these tips are helpful for you, because it's all about the dynamic dual, right? We have to check the ignition system entirely. It starts with checking the wiring, the ignition coils, but don't forget to check the spark plugs too, because it's always a cause and effect, especially if we have bad coils and the spark plugs are falling out. We want to be able to fix the total problem along with fixing the root cause of the problem as well. So always inspect your spark plugs at the end of your troubleshooting when you have ignition coil failures. And that's all about doing the job right the first time. Thank you for listening.